Hello class, and welcome back to Management 322. This lesson is all about the project management plan. Today you'll learn basics about what a project management plan is and some best practices to incorporate on your own projects. We'll delve into common organizational structure of civil engineer project teams, along with each member's role and responsibility. We'll talk about risk management, what common risks are, and how you can include them in your plan. And finally, we will talk about the relationship between scope, cost, and schedule, and how to include them in your project management plan. In a previous lesson, you were introduced to the project record, a living repository that contains all documents that pertain to your project. A notable item to include within the record is known as the project management plan. The Project Management Institute defines this plan as the document that describes how the project will be executed, monitored and controlled, and closed. In other words, how are you going to do your project? History is laced with examples of large and complex projects that simply could not have been completed without a well-thought-out plan. The construction of the iconic Golden Gate Bridge in San Francisco, completed in 1937, was a remarkable engineering feat. Its project management plan included innovative strategies such as the use of a safety net, which saved the lives of 19 workers during its construction. NASA's Apollo program, which culminated in the moon landing in 1969, required precise project management to achieve its historic objectives. The project management plan for the Apollo missions involved meticulous coordination and thousands of scientists, engineers, and support personnel. It resulted in one of humanity's greatest achievements, as Neil Armstrong became the first person to set foot on the lunar surface. You may have heard the old adage, if you fail to plan, you plan to fail. This couldn't hold truer when managing any type of project, including what we do as Air Force civil engineers. Project management plans can and should be tailored to fit the precise needs of your project. You may recall these 10 workforce competencies that both the CE School here at AFIT and AFCEC have adopted. A good project management plan provides a comprehensive framework to address each of these competencies, specific to your project. You can start forming your project management plan by asking questions that relate to each competency. What will determine the scope of this project? Who will be working on the project team? What will each person do, and who has the authority to make changes? How are we going to communicate with one another? Are we doing anything in regards to project risk? How will we measure quality? Answering these questions before work starts, including them in a plan, and communicating that plan with others will amplify your chances of success. So who is responsible for creating the project management plan? There's no blanket Air Force instruction that mandates the creation of a specific document, but your organization or leadership may have internal requirements for such deliverables. We've told you to own your projects. When you assume such a position, it will largely fall on the project manager to develop, maintain, coordinate, and implement a project management plan. Work with your team and own this process. Planning can often begin far ahead of project execution. It is not uncommon to spend more time developing a project management plan than it takes to construct a requirement. Take the Hoover Dam and the Black Canyon of the Colorado River, for instance. Initial planning for development began in 1922 and continued until President Coolidge signed an authorization bill in 1928. It wasn't until 1931 that drawings and specifications were made available to interested contractors. Construction of the dam itself took only 5 years, and it was complete in 1936. This compared to the planning phase that spanned over 9 years. Our own Air Force B-Camp process looks at prioritizing and programming infrastructure projects within a window of 5 out years. Bottom line, when looking at the typical Air Force construction project lifecycle, we want to develop a project management plan early within the planning and programming phase. Now you may be wondering exactly what a project management plan looks like. The product will depend on the scope and complexity of the project at hand. A plan for a $90 million Milcon project will be vastly different than a small contingency construction project that you execute within your squadron. The remainder of this presentation will include some best practices in regard to creating a project management plan, but it is largely introductory. A great idea would be to ask around your current unit and see what project managers have implemented in the past. This utilizes lessons learned from past projects, and project scopes will likely be similar to your own. Many large organizations, both in industry and in government, may have project management plan templates as part of their organizational process assets. The U.S. Army Corps of Engineers and AFCEC both have templates for capital projects. AFCEC's Project Execution Playbook highlights the importance of having a project management plan at the outset of project design. They note that the project manager should sketch a project team organization chart and set the rules to be followed for communication. The plan should include information about who calls whom, who gets copied on information, how many copies of which A&E submittals to go to whom, and so on and so forth. Make sure that everyone understands each other's roles and responsibilities. The example here clearly shows project team hierarchy from operations flight commander to project manager to shop or element leads during an in-house contingency construction project. Additional information showing who reports to who, the arrows, and how project team members communicate should be included. Types of communication, like status, progress, or forecast reports, as an example, can be defined in your plan, along with the recurrence and medium of communication. Roles and responsibilities for each team member can also be included. Codify this in your project management plan and ensure the team is tracking. Setting this expectation early will help clarify what each team member's job is, and this is also a great way to start addressing some of those project management competency areas, such as project team and stakeholder management. Here is another organization chart example for a project where a contract is involved. Note that the project inspector is acting as the contracting officer's representative and reports to the project manager. Daily reports of the project are expected using the Air Force Form 1477. If modifications or change orders to the contract are necessary, then the project manager can reach out and communicate with the contracting officer, who is the authority to make such changes. Oftentimes, the PM may serve as both the project inspector and the contracting officer representative, or the Corps may be communicating directly with the contracting officer. This is just starting to scratch the surface of what to include in your plan regarding change management. A later lesson will delve further into details, specifically related to changes in construction contracts. Another crucial competency area that deserves recognition in your project management plan would be risk management. Defined, risk is an uncertain event or condition that, if it occurs, has a positive or negative effect on a project objective. Oftentimes in the Air Force, we associate risk with being negative. You hear of commanders being risk adverse or not willing to accept risk. In the project world, this couldn't be further from the truth. Per this definition, risks can be either good or bad, and we have terminology to go with that. Risks that produce good effects when they occur are referred to as opportunities. Risks that produce bad outcomes are known as threats. There are various tools and techniques to help identify, qualify, quantify, and capture risks associated with a project. It begins with looking at risk in terms of this formula. Risk equals probability, or the likelihood of something happening, multiplied by the impact. What is the overall effect on the project? Risk impacts in construction are largely measured in time or monetary cost, but could also include quality, resource, or scope impacts. By looking at the likelihood of a risk occurring and its impact, we can begin to prioritize and determine which risks to care about most. Listed are some very common risks that occur in construction. Rain is often seen as a threat that will delay concrete pours or other activities. Similarly, weather could also be seen as an opportunity when ambient temperatures reach a suitable level to apply a protective coating. Experience of the project team and labor force can also be considered a threat or opportunity depending on level of expertise. Material production in recent history has been constrained by supply chains, resulting in long lead times and lack of availability. Site conditions, including land ownership, geotechnical characteristics, existing utilities, and use can all be associated with project risk. To learn more about risk management practices and how to incorporate them in a project management plan, look at taking our Management 422 and 437 courses here at the Civil Engineer School. The last item we will address in this lesson revolves around how the competency areas of scope, schedule, and cost relate to one another. These three competency areas are commonly referred to in the project management world as the triple constraint. In the prior scoping lesson, a work breakdown structure was introduced to methodically break down project work into manageable chunks. This procedure is an effective way of identifying activities and capturing all the work and only the work required to complete your project. Once a WBS is established, the work of estimating durations and sequencing activities can begin. Imagine you are tasked to replace an HVAC chiller at a communications facility. Likely, you will need to have the new unit installed and operating before you decommission the old unit. How these tasks relate to one another is critical in producing an accurate project schedule. The time it takes to install the new unit will drive the duration the old unit is still operating. Additionally, the complexity and time frame required to complete these tasks will influence their cost. A larger and more complicated unit may require specialized technicians to install it, driving up the cost. Or perhaps the old chiller has failed, demanding the new one be operating as soon as possible. The government then gets billed at an emergency rate due to the response time. Other project assumptions and constraints that involve special equipment, material laydown, contract delivery methods, or contract type may also influence our project. The aim of this example is to show you how closely the areas of scope, cost, and schedule are tied together. Both our schedule and cost are built from the project scope developed in a work breakdown structure. Being able to clearly identify what is in scope, what is out of scope, should be a primary consideration in your project management plan. So congratulations! You have made it to the end of the project management plan lesson. This also concludes the planning and programming module. Please reach out to the course directory if you have any questions, and best of luck on your module quiz.